Swayam Prabha. Digital India. Educated India.
Hello, Namaste. I am back with the second lecture of the module 5, where we were discussing about the GIS data quality. I hope all of you have understood what do you mean by a data quality, how data quality is important for your data. Okay, but now we'll go into much more details of what do you mean by positional accuracy. So that is also very important. We discussed partially this in the previous class, but we would also look at more aspects in this particular class and sources of error. So we discussed some errors that may creep in, but we did not discuss what are the sources of error. So we will look at source of errors, how do we rectify it also in the next two lectures. And as I said, the concept that I would cover in today's class is measuring positional accuracy. How do you measure a positional accuracy, lineage, then factors affecting the spatial data quality, sources of errors in spatial data, and factors affecting the reliability of spatial data. Reliability is extremely, like your completeness and logical consistency, reliability is extremely important in terms of your spatial data. How reliable is your data? So you have to give an idea to the user that how what is the reliability aspect in your spatial data. So that is extremely important when you are actually putting out this data in a public domain that can be used by many people. So if that has to be done, then the reliability aspect has to be considered in a proper way. So when you are looking at the measurement of positional accuracy, this is normally measured in terms of root mean square error. Okay, the square root of the average squared errors, that is, if you have predicted error and the actual error. Okay, so it is the root mean square of the averaged errors that is there in the entire data set or the entire data layers that you consider. That is how it is measured. So it is usually expressed as a probability that is no more than p percentage of the points will be further than it's not further, it's farther than s distance from their true locations. Okay, so p percentage of points will be farther from the distance s from their true location. So how many is displaced from the true locations? Loosely we say that RMSC tells us how far the recorded points is in the GIS are from the true locations on the ground. For example, this had to be your location. Okay, when you have mapped it in the database, it has shifted to this location. So this is the shift that you see in your true locations. That is what is measurement by the RMSC. So once you calculate the RMSC from the real world to your data model, then whatever the data that you have recorded can be easily shifted by so many points or so many units. So that is how you improve your data, how you improve your positional accuracy. For example, when I am actually looking at a satellite data, the first thing is we go to the field, collect the data, we know what is the position of that particular data, come back, tie the position to the particular information. So for example, intersection of a maybe road, a building that is already there from a very long time, very easily identifiable building. So all of these are the informations that you have to collect. So once you know this, tie the information to the real world coordinates or real world information that you have already got. So now you can compare what is the error. So with that, shift the particular point so that you almost have the zero pixel error or zero error in terms of, or zero RMSC. If that you can achieve, then you have the best positional accuracy for a particular data. So it can also be, there are various things that you have to consider when you are looking at positional accuracy. The first and the foremost thing is put it in the same coordinate system. Look at the spheroid and datum, it has to be same. If it is same, then there is no issue in terms of most of the maps would overlay. Okay, the first thing that you have to look at, once both of them are matching, they overlay. The next thing that you have to look at is what is the kind of measurement locations accuracy that you have considered. If you have considered exact measurement locations accuracy, then you know where that particular point has to be, so you can shift a particular point, or if it is extremely accurate, then you can maintain the data set as it is. Then the media stability, what kind of stretching, folding, wrinkling of maps or photos may have happened if you have a physical map. Okay, then human drafting and digitizing errors, this also can be easily found out. Nowadays there are huge number of tools that they have developed in terms of understanding this interpreting errors. Okay, so using those tools, most of these errors can be either removed or rectified. Then you have resolution or accuracy of drafting and digitizing equipment. So when you are actually looking at a drafting equipment, you know what is the accuracy of that particular equipment. So that is extremely important in terms of looking at drafting or a digitizing accuracy. So if you have understood all of these, okay, in your positional accuracy, then your data is quite accurate in terms of measurements. Okay, so please keep in mind, the first thing that you have to look at is what is your coordinate system, what are the projections that has been used, whether they match the datum that is a reference point that they have used, and what is the accuracy of measurement on the real world to your data model, that you have to probably look at. Other things are digitizing errors, that normally if you are now digitizing, now automatically you can look at it without any issues, but these are the issues that you have to keep in mind when you are actually looking at errors, the major errors. Okay, so let me give you some examples. For example, here the first thing is horizontal accuracy. So when you look at this, RMSE of a building polygon is based on comparison of horizontal coordinates. That is, if I am trying to see these polygons, it is dependent on the horizontal coordinates and all the nodes of the footprints of a building in GIS with the corresponding reference value on the ground, that may be through your GPS or any other ways. Okay, so you have to look at the corresponding points here. Look at the horizontal coordinates first, okay, of all of these buildings, fine, or look at the sample number of these buildings, then look at the nodes of footprints or the coordinates of those nodes of the footprints to the real world, match it to the real world, you know what is the difference. If there is certain difference, let us say a difference of 2 meter in a image that I have tied, so shift your image by 2 meters, so correct your image by 2 meters, or your whatever the accurate measurements that you have already done, those measurements will be having an additional of 2 meters. Okay, so such such things has to be taken into consideration when you are looking at positional accuracy. Vertical accuracy, most of them may not need an vertically accurate data, because most of them work on a horizontal data, but when you are looking at a vertical accuracy, then it is extremely important. For example, when you are looking at this, okay, you have a building here, so this, when you are looking at comparison of vertical coordinates of all of the nodes of the footprints of the building in GIS with the corresponding reference values. So there are certain values which you can consider to be as a reference for this building, so you have to look at those reference values. Also, there are certain measuring instruments which can be used to measure the height of the building. So if you have those measuring instruments, so you can measure the height of a building and use it for such analysis, so in order to see whether it matches the real world phenomena. The next thing that is that we have to understand is lineage, how the record of that particular data has been created in the database, then how it has been transferred, how it has been used, applied, and now used by someone else. So how it has come over age, so that we have to look at in terms of lineage. So it is also an indicator of accuracy. How accurate is your data? If your data is completely old without updation, and you are trying to find out today's scenario of maybe growth, so you will not be able to understand it because your data would not give you exact point of in that particular map. Then origin of data comprise of source materials including date, original application, data capture method. This I have already explained in my previous lecture. Digital maps can be established based on photogrammetric measurements or by digitizing the existing maps. So the best method to get accurate values is using the photogrammetric measurements, and if you are not very good with photogrammetric measurements, then look at digitizing existing maps. So attribute data is taken from the public registers or from direct in from the field. So this source has to be mentioned in your data, but this may not be sufficient only to know the data source, but also the data collection, how the data has been collected. Even if that data has been collected from certain place, so how that particular data has been collected to represent in that place has to be known. Okay, how the method of preparation of that particular data is also another point that you have to look at. The data generated from the source, whether it is satellite, surveying, etc., are always preferable to maps, as they are consequently subjected to less errors. So you prepare it as maps, and because of which you can look at what is the accuracy of that particular map and then use it into your database. So there are certain factors affecting the quality of the spatial data also. So when you are looking at this, data itself is a first quality that is affecting the spatial data. For example, are all your data up to date or not? For example, that's what I mentioned in my previous slide as an example. If your data is 10-15 years old and you are trying to model today's phenomena, it may really not capture a certain phenomena. Let us say we are capturing a phenomena of how the urban growth is happening maybe in a particular city. So what you try to do is that first thing that you take here is you have let's say satellite data of 1990s, okay, and then you have a satellite data of 1995 and a satellite data of 2000. Okay, you have extracted the land use. Now what you want to do is that you want to know what is the growth that is there in 2019, but without understanding what is the growth between 2001 and 2018, it may not be possible to find out what is the growth in 2019. Why? Because for example, a particular city, there may be an industrial region that has been set up in 90s, there may be an IT hubs that have come up in 2000s, and there may be certain agents that have fueled the growth in 2000, 2005, etc. The growth may be higher spikes or lower spikes. So if you can understand this kind of dynamics, then only you will be able to model it for 2000. Otherwise, that particular area where the growth may be in a higher spike or maybe in a lower spike will not be captured effectively by your model, and that leads to an issue in terms of understanding. Okay, then the completeness. Is your area coverage complete or partial? When I also say this, your completeness in terms of also collection of data, you should also you should also have an heterogeneous data features that is spread all over the data region. It should not be only in particular region. For example, if you are looking at urban area and a buffer, your data collection should be both in the urban area and also in the buffer. If you are only collecting only in the urban area and not in the buffer, then your data is actually not incomplete. The way you are collecting data is actually inaccurate, because it's not representing the true world phenomena. Consistency of your data is another important factors in spatial data quality. So when I say map scale, the standard description, the relevance, the way it is represented, so all of this should be consistent. Okay, or when you digitize it, make it consistent. So then it would be much easier for you to look at the data quality. Then accessibility, for example, the formatting, the copyright, the cost involved. So all of these are some factors that affect the accessibility. Then accuracy and precision. Okay, as I said, both data may not be both accurate and precise, or it may be accurate and or precise depending on the situation it is in. So look at the accuracy and precision in terms of observations, density of observations, positional accuracy, attribute accuracy, qualitative and quantitative both, then topological accuracy. So when I say positional, it is almost quantitative, and when you are looking at attribute accuracy, it is more of qualitative, sometimes it's quantitative. So look at both qualitative and quantitative aspects and topological accuracy. So if you have looked at all of these, most of your data is will be quite accurate in terms of representations. Sources of errors in data, if there are certain source of errors in data, the way it is captured, way it is measured, so that may also affect add as a factor that is affecting the quality of a spatial data. Okay, so when we look at that source of error, the first source of error is a user, that is through data entry and output faults. Okay, that is the first thing that a user makes. Okay, so the first source of error, the major source of error that I would assign is the source of error in a data. So also the choice of a data model, this is extremely important in terms of when what kind of data model you are using. So if a user is using a wrong data model, then then your entire spatial data is not going to be propagated in a proper way. Then the bias, so that bias should not be there. It has to be a neutral agreement between any phenomena in order to assess that particular data properly. Numerical errors in numbers may creep in many times because of a huge data sets. Limitations of representation of numbers by a computer, this may not be valid today, but in certain old systems, yes, it is. There are certain issues, limitations when you are looking at limitation of representation. Then you have source of error in derived data and results of modeling and analysis. So this is also extremely important in terms of understanding the error. Then problems with map overlay, classification, choice of the analysis model. So I have spoke about overlay and classification already. Then the misuse of logical consistency, if it doesn't have, then you have a source of errors in data. So please look at all of these. Then I have also given some the probable source of errors. These are inherent instability of a phenomena itself. For example, random variation of most phenomena, building size. If you are looking at 5 years and if there is some issue as changing building size and you are taken that as a reference point, so probably that also can creep in as an error. Measurement instrument comes as an instrument error or a surveyor error. It may be model used to represent data that I have already spoken, whether what kind of spheroid it has been considered, what kind of classification system it has considered, then data encoding, data processing, and finally the thing that you have to look at in terms of data error is propagation or cascading from one data set to other. So if you have an error in one data set, it actually propagates to all other data sets, because of which the crunchiness in the data set may increase, and that may lead to more errors. So to just give you an example here, if we consider these lines that I have digitized on this particular map here. Okay, so I'll just use some other color. I have digitized all these maps here. Okay, so if you look at this, this is an 1:2 it is a 1:20,000 map. So if you are looking at this particular map, if this is the error and the thinnest line that you can see is 0.1 to 0.2 millimeters. So at a scale of 1:20,000, if we look at it, it is almost close to 12 feet or 12.8 feet to be exact. So which means to say that you can look at 4 meters, that is equal to 12.8 feet. Yet a small deviation in this will give you a 4 meter error, 4 meter error on the ground and 12.8 feet error, 4 meter error on the map and 12.8 feet error on the ground. So which means to say that the registration accuracy would be going wrong. So when you are trying to measure the distance, when you are trying to measure the building area, etc., then you are actually making a mistake. So when you are looking at mesh impression, the coordinate rounding error is in the form of storage and manipulations many a times, and some other unknown errors can also occur. These are some errors that I have put forth, but when you are actually working, you will understand there are a lot of other challenging errors that you may see when you are looking at the spatial data. So when we are looking again at these things, the word error in this context does not include only faults but also statistical concepts, the means for example the mean variations. So that is also an error in terms of the spatial data, where if you have considered the entire data, you have considered a mean of that data. So what is the amount of error that it can creep in also is another kind of error. The most difficult source of error are those that can rise as a result of certain kinds of processing. Okay, many times we use certain processing when we do not have an access to high computing capability systems. So we use an approximate model of or processing methods which are computationally not intensive, that can also provide certain errors into the entire data model. So they can be detected by the knowledge of data along with the data structures and algorithms that are used. So if you understand all of these, the algorithms, the data structures and the data that have been used, then these errors can be easily removed from your database. So the factors, in case you are looking at reliability of data, which is extremely important in terms of spatial data, how reliable is the data that has been generated by you, in case you are actually transmitting the data for different users to use in different applications, then the reliability is extremely important. So how do you find out the reliability? The first thing that any time that you look at is lineage, the age of data. Okay, if it is possible that old data are unsuited as they were collected according to the systems of the standards that are no longer used or in acceptable form. It can be this issue, or it can be the old data that may not be giving the information that is there today. For example, in 90s we had the data at a resolution, satellite data at a resolution of 72 meters and 36 meters, but today we have a data at 1 meter resolution, at a centimeter level resolution. So if you are comparing a centimeter data with data which is 72 meters or even 1 kilometer data, then that is where the first reliability goes as far as your data measurement is concerned. Whatever you are measuring, measure at so that the sources are actually same. Basically weed out the old data which may not be effective enough in capturing the phenomena. Then data sources may simply be old to be useful or relevant to current GIS projects, as I explained. Then the past collection standards. So this is extremely important in today's context. The standards of either collection, representation, depiction, all of these have been standardized to a very large extent. So past collection standards may be quite unknown in terms of, or maybe erroneous. So in order to have or have a better data model, it is better to actually avoid old data than and create a fresh data, and which may actually affect your entire data model. If these factors are considered, your data may be quite reliable in terms of accuracy of that particular data. For example, here I have taken up a survey of India topo sheets. Okay, and here is the Google Earth. Now Google Maps can go up to a distance of you can get a information at a 10-meter distance, and the accuracy of that information as per many sources that has been represented in research, it is +3 to +6 meters. Okay, it can vary across regions to at least 10 meters. So now if you have that accuracy, the horizontal accuracy is about 10 meters, and when you look at the SOI topo sheets that is there, that is normally not updated very frequently and has been in time from 1970s onwards. So if you are trying to look at these two, then this old information may not be logically important in terms of analyzing this particular data that is there in today's context, but this can provide a vital source of information for your data model. Okay, for if you are trying to find out what was there in 1970s and what is not there today, so in terms of extraction of what was there but then corrected according to today's standards, may be the best model that you are, if you are looking at the old data versus the new data. Okay, the corrected data can be then used to compare with the new data. So correction levels of what kind of correction can be done can be very well known for a GIS user. Anyone who has the who has some experience of handling GIS data can easily start looking at such phenomena where they can easily extract information and then convert it in such a way that it becomes more reliable data in terms of accuracy. So you have to look at 2-3 different sources of the same data. Once you have understood the source, then you will be able to understand how reliable is this particular data. Then the area information or the coverage. So yeah, it may be that most of the data that you have considered is uniform. For example, if you look at some of my publication, some of the areas that I have considered, for example, if I have working on Kolkata, the entire Kolkata metropolitan region. So if I have considered 10-kilometer buffer, so many of the places, many of the years, I could not get at least 10% of that data, of the spatial data that is available in that 10-kilometer buffer. So what we did, we tried to always use a similar buffer, neglecting that part of the region. So if you have removed that entire part of the region for your entire course of the day, so that would give you some meaningful information in terms of reliability. Otherwise, if you have in 1 year you have that data set, and other one you do not have a data set, you cannot compare it pixel by pixel and understand what is the change. Okay, so always having the area information or change should be on the same polygon or the same region that you have considered. Options can be used to obtain more data, surrogate information from remote sensing also. So map scale and resolution. So this is also extremely important in terms of when you are looking at the reliability. So whatever the maps are used, if you can try and get the large scale map, it would be more important in terms of extraction of topological details. But usually we have more detailed legends in these large scale map. So look at large scale map. So again, let me repeat, we understood in my previous session, we have two we have large scale map and we have a small scale map. Large scale map gives you a large amount of details, whereas the small scale map gives you very less details. When I say small scale maps, these are 1:1 million, 1:50,000 maps. When I say large scale map, it can be compared to 1:1 million, 1:10,000, 1:25,000 is a large scale map. Okay, so keep this in mind. So look at the information that is actually necessary. It is important that the scale of a map matches the required area of the study. So for example, if you are trying to study the entire subcontinent of entire India as a study region, and if you are trying to use 1:5,000 or 1:10,000 map, it may be foolishness, because when you are trying to process this entire data set, it may not work out in terms of giving you an accurate data or generating an accurate data. Instead, if we use data at if we use certain ways of generating this information, wherein you are using maybe 1:50,000 maps or even 1:50,000 maps, then it can be extremely eventful in terms of mapping the entire India and extracting its details. So, and small scale maps most probably, as I said, have insufficient details. Okay, so now the user has to decide, small scale map has insufficient details or it has very less details, whereas a large scale map has sheer volume of details. So the computing capability here versus an no computing capability that is necessary, very less computing capability that is necessary. So all of these factors has to be considered before you look at what is the reliability of your spatial data. Okay, then density of observations. What is the density of observations that you have? Maybe reasonable measure of data quality. Not always it is an important part, but there should be certain ways of analyzing the density. Then relevance. The variations in the frequency in pixels are represented by a histogram, for example. So this can be helpful in terms of looking at what are the training sets that has to be considered, what are different training groups that has to be considered, and what are the distributions. For example, the modal distributions that it can have in when you are trying to classify a particular data. So these are certain things that you have to look at, and the last thing that is very important is accessibility. So as I previously said, not all data is freely accessible. One set of data might be free to use in one country and might be the state of secrecy in the other country. So look at what data at a specific country it is used, or it may be even between the state, even between the corporations also. Cost and format problems also bridge a gap. Now the most data that India is producing is interoperable, so most of them are the interoperability standards. So looking at this, yeah, this may not be a much of a big issue. Extensive and reliable data is often quite expensive to obtain or convert. Yes, this is the very important part. Most of the private generators who actually generate extensive reliable data are extremely expensive in terms of obtaining this particular data. Then you have the cost and copywriting. So cost I have already spoke. The major thing is copyright permissions for each and every country varies, and it may be advised to check legal situation in each of this country. And most importantly, the copyright permissions of the data that may be available publicly, but in order to use it in your own data model, it may need certain permissions, certain cost that may be involved in order to obtain those permissions is also important. So without that, it may not be put into your, it may not be used into your database. Okay, so another error that may come in for the checking the reliability of data is a numerical error. So when you are looking at the computer processing capability or the ability to store and process the data at required precision, that is also very important. So if your precision length is 6 points, so if your computer is able to store only at 2 points, then that is where your numerical error starts. Then there is insufficient precision maybe lead to calculation errors also. For example, if you are calculating the length of a road or area of a polygon, so it may also create a certain amount of precision errors in a data. So number of polygons will actually populate it to much bigger errors. Okay, so then the last thing that I would speak in this particular class is the fault due to assumption concerning the exactness of spatial data. So we think that we assume, basically we don't think, but we assume that most of the sources of data that has been considered is uniform, and digitizing procedures that one may have used is infallible. So which if has to be understood, you have to look at the data. Probably once you look at the data, you will understand how consistent or inconsistent that particular digitization has been. So when you look at most of the people who extract map boundaries, they look at only intersecting boundaries and reconnecting the line network, which may not be true in the real scenario. Boundaries can be sharply redesigned and drawn, so it has to be properly redesigned and drawn whenever you are considering the boundaries. All algorithms are assumed to be run in a deterministic way. Okay, all algorithms are considered to be true, all algorithms are considered to be the best. So but it may not be really true in terms of real world scenario. So that these are certain things that we have to use when we are looking at how we are mapping in any of the traditional ways that are there, and how we are mapping in the digital ways. So if these ideas are considered, then it would be the same traditional way of mapping, and error that accumulates into the map when you are creating a map or a data output. So to summarize today's class, we looked at measuring positional accuracy, how different methods of measuring the positional accuracy. We looked at the lineage and how the data has been transferred over a period of time. Then factors affecting the spatial data quality, errors in the data, spatial data. Then factors affecting the reliability. So we looked at all the factors starting from how the generation happens and what is accessibility and the cost that is necessary. Then probably in the next class we would look at the pixel accuracy. For example, when you are using a raster data, what is accuracy measures, how do you calculate an overall accuracy, how do you calculate a kappa statistics, how do you say that whatever the land use that you have generated using a raster data or a raster data model, you can satisfy the criterion of providing the accurate data. So we look at all of these in probably in the next class. So till then, Have a nice time. Thank you very much.